Hello, lovely math students. Um, it's Miss Wade again, here with another video, getting you ready for some more equation solving. Normally right now I'd have a warm-up for you, but we're going to kind of skip that. I really want you to concentrate on your notebook, getting that as up-to-date as possible. You're not going to be starting a new formal notebook page today, because there's not going to be a new essential question or a new topic. Today what we're going to be doing is kind of practicing all kinds of equations, everything from when we started solving equations and just seeing how the steps that we've been talking about apply to every type of equation that we've studied so far. So grab your notebook, and if you want to start a new page of notes for these, that's great, or you can just continue to add to the notes that you took last time. So let's just jump right in. We've been talking about equation solving for a while now. And the idea here is that we've built these steps that you see, and they look slightly different than they have before, but the basic idea is that the first thing you want to consider is whether or not you're going to simplify. And once you get done simplifying, if you can, that's when you get into the solving of equation steps. So simplification basically comes down to two things, either combining like terms or distributing. Once you get done with simplification, you can't distribute anymore and you can't combine like terms anymore. You want to actually solve the equation, get the variable by itself. That's what solving an equation means. To do that, you create clever cancellations and do the same thing to both sides over and over and over again until that variable is by itself. So when we take a look at this equation here, 4c equals 40, remember that there's two sides of an equation, and those two sides are divided by the equal sign. So that's what we're going to create there with a little dotted line. And then we ask ourselves, well, on the left side, can we simplify? And the answer is no. Nor on the right side can we simplify. There's really simply nothing to do. And so in this particular problem, we won't be doing any simplification. We're going to jump right into creating clever cancellations and doing the same thing to both sides. This equation says 4 times c equals 40. And whenever you want to create a clever cancellation, you do the opposite of what you see. So here we see multiplication, so we're going to create a cancellation by dividing. And what are you going to divide by? The thing that's next to the variable. So in this case, it's a 4, and so literally we're just going to divide by 4, but we make sure to do it to both sides. Now these 4 canceled, and we have c left over on this side, and then 40 divided by 4 is 10, and that's done. And how do I know we're done? Because the variable's by itself. This is a one-step equation, and it just takes one step to do. This equation is also a one-step equation, and it just involves kind of thinking through the idea that can you simplify on independent sides, and the answer is no, you can't, because 6 and f are not like terms, so you can't combine them. There's no parentheses, so no distribution, so you're going to jump right into creating clever cancellations, and what you want to do is get rid of that 6. Well, we have 6 plus f this time, 6 plus the variable. And so in order to get rid of it, we're going to subtract. So we're going to subtract 6 from this side. Remembering we have to do the same thing to both sides makes us subtract 6 on that side. These cancel. All we have left is f, and that's going to equal whatever 15 minus 6 is. And I do believe that's 9, and since the variable's by itself, we're done. Now here's something slightly more complicated, but the steps are always going to be the same. Can we simplify? Well, we can simplify on the left side. See how we have parentheses? This is going to clue us in that we're going to need to distribute. So we will distribute the 2 into the parentheses on the first term. 2 times x is 2x. And then we also have to distribute the 2 onto that positive 7. 2 times 7 is 14. And that's going to equal 46. We didn't simplify on the right side of the equation because 46 is nothing to simplify. And now that we're done simplifying, we're going to create clever cancellations. Now there's going to be a couple steps involved in this. We're going to start on the side of the equation that has the variable, but get rid of the term that doesn't. And so I'm going to subtract 14. Doing the same thing to both sides gives me this cancellation, and I have 2x equals 46 minus 14, or 32. And then we have to think about, do we have to create another clever cancellation? And we do, because the variable is not by itself. We are creating this cancellation by dividing by 2 on both sides. And these 2's cancel. And we have x equals 16. And since the variable is by itself, we are done. Every algebra problem will involve the steps that you see right here. So let's do another one. Can we simplify? Yes, we can. On the left side, we've got a couple of terms that are like terms, and that's the 2x and the 3x. And so to combine them, 2x's plus 3x's is 5x's, and we've taken care of those guys. Now, plus 4 comes down because there's nobody to combine it with, and that equals 24 because there's nothing to simplify on the right side. Now, it doesn't look like we're going to need to distribute because there's no parentheses and never has been, so we're going to jump into creating clever cancellations. I'm going to subtract 4 from both sides. Do you see why? I hope so. It's because it creates this cancellation right here, and I have 5x equals 24 minus 4, which is 20. And now I need to get rid of that 5. To do that, I can divide on both sides by 5. And I have x equals 20 divided by 5, or 4. And the variable's by itself, and so I'm done. What about this one? Can we simplify on the left side? Can we simplify on the right? I hope you said no, because h and -3 are not like terms. There's no parentheses, and so there's nothing to simplify, so we don't even do that step. We're just going to skip over it if we can't do it. Now we're going to create a clever cancellation by getting rid of that -3. It's h minus 3, and so in order to create a clever cancellation this time, we're going to add 3 and make sure we do it to both sides. These guys cancel, and we have x equals 7 plus 3, or 10, and we're done because h is by itself. All right, here's another one. Starting with simplification again. Can we simplify on the left side? Yes. I see parentheses, which makes me feel like I want to distribute, which is a great strategy. So we're going to distribute the 2 onto that 1 and say 2 times 1 is 2, and then 2 times -x is -2x. Now that plus 3 is just kind of hanging out there. There's nothing to do with it, and so we're just going to bring it down. Same thing with the -8, nothing to do on that side. All right, so are we ready to create clever cancellations? I'd say no. And the reason why is because I have this 2 and this +3, and those can be combined. 2 plus 3 is 5, and I've taken care of these guys. And then -2x hasn't had anything done, and so it comes down, and that equals -8. Okay, so it looks like simplification is done now because we combined all the like terms and we distributed. We had to do both this time. And we did them in whatever order made sense to do it. Now we're going to create a clever cancellation by subtracting this 5 from both sides. That gets rid of these guys, but notice it does not get rid of the minus sign in front of the 2. And so we have -2x equals 8, -8 minus 5, or -8 and then more -5 places. So 8, 9, 10, 11, 12, 13, and so we have -13. All right, and then we will do one more cancellation by dividing both sides by -2. These cancel, and I'll just pull this over here, and we have x equals, now notice that we have a negative over a negative, which is positive, and so those go away, and then we have 13 over 2. Now you could leave your answer just like that, that would be fine, but if you plug that into a calculator, 13 divided by 2, you get 6.5, so that is a good answer as well. And we've seen this problem before. Sometimes you end up with fractions, which can turn into decimals. That's fine. All right. All right, here's a bit of a crazy one. Let's see what we can do with this. Can we simplify? Let's create our sides first. A lot of room for this one. Might not even have enough room. In fact, I'm going to pull this down a little bit just to give us enough room. So I see parentheses, and so I'm going to distribute, but it looks like there's two places where we're going to distribute this time, in this spot right here and in this spot right here. I'm going to get rid of those so they doesn't get confusing. It's confusing enough, am I right? So I'm going to distribute the 5 on this 3 and say 5 times 3 is 15 because it is. And then 5 times negative x is negative 5x. And now I'm going to take this 2 and distribute it onto the 3 and get 6. And then 2 times negative x is negative 2x. And that equals the 14 that's kind of hanging out by itself. So we have distributed successfully to get rid of the parentheses. Now this new equation is not simple yet. It's not simplified completely because I can combine like terms. And there's actually two places where I can do that. There's 15 plus 6, excuse me, and there's negative 5x minus 2x. So there's two places where we can combine like terms. We just kind of match up the terms. So 15, excuse me, 15 plus 6 is 21, so we've taken care of these guys. And then negative 5 minus 2 more is negative 7x, and these guys are done, and that's going to equal 14. Now on the left side, we've got a 21 and a negative 7x. Those are not like terms, so we can't combine them. We don't have any parentheses anymore, and the 14's hanging out by itself, so our simplification step is now done, and that's when we're going to move into creating clever cancellations. So we're going to start with subtracting 21 from both sides. Do you see why? That's because you want to start on the equation, the side of the equation that has the variable, but get rid of the term that doesn't. That creates this cancellation here. Notice that we have not gotten rid of that negative sign in front of the 7, so we have negative 7x equals 14 minus 21, which is negative 7. And then we're going to divide both sides by negative 7 to create the last cancellation to get x by itself. Those cancel. X equals negative 7 divided by negative 7, which is 1. And now we're done. These steps are going to be used over and over again. Sometimes the simplification steps will be in slightly different order. You might have to do them a few times, but it all still just comes down to these steps. So that's really it. Not much more to say about equation solving. It comes down to some very basic steps that you will apply cleverly to get to that variable. You've got another practice on a quizzes, and you can click on that from the Google Classroom. I hope that this was understandable, and we've got a quiz coming up pretty soon, you guys, so yeah, we'll keep supporting you, and make sure that if you have any questions that you let me know so I can be helpful to you. All right, y'all, have a good day.